Hi guys, I hope you are fine. Me too, I'm fine. We thank God for this opportunity that He has given to us so that we can learn together. And I can confess that God is good because He's been good to me, even through His Son Jesus Christ, who saves us and forgives our sins. And so, guys, let's now come to the question. I'll do the second one, you do the first one. Guys, the second one is a bit difficult. So I will do the second one so that you can be left with the easier option. So guys, let me start the question. First, I read it. Given that z is equals to x over y log e, that is log y to base e, that is ln y, prove that partial differentiation with respect to y, that is partial differentiation of z with respect to y, is equals to x partial differentiation. This one, guys, is supposed to be squared here. So that one I left it out. So just take note of that. That one was second differentiation. That is second partial differentiation of z with respect to z, to x and to y. So guys, we now start to do the question. So we want to prove that this side is equal to this side. So guys, what I will do, I will come and now begin. So, but before I begin, guys, I will have to use this equation. So let me write it down so that we may remember it. That is the product rule. The product rule is written like this. I write it here. Is d all over dx uv. This one is supposed to be now u dv all over dx plus v du all over dx, like that. So guys, as we do this question, we should take note of that because we shall be using that. So let me now start from this side, and I will write like this: partial differentiation of z with respect to y. This one now is going to be, we come to this equation here, x ln y all over y. When we are doing partial differentiation, guys, we are supposed to now, if we are doing with respect to y, we consider x as a constant. That is like 2, 1, or any other constant. So guys, I will consider this one as a constant. And let me give this first portion, I give it u. This portion I say is u. That is, let me just do it like that, guys, because it's not hard to differentiate. But anyway, I will write here. I can write with this biro pen. So I will say, let me use this other one. U is equals to x all over y, like that. So that I will have, that is, now I will have partial differentiation of u with respect to now y. This one now is supposed to give me, this is a constant, so we can put y here, up here, so it is y raised to minus 1. So it will become y raised to negative 2. That then it will be like minus 1 all over y squared. Guys, I have followed a shortcut there because I should have written y raised to negative 2. But now I have chosen just to put it like that. Otherwise it was supposed to be y raised to negative 1, and this x is there. We have said this x, we consider it as constant, so I will put it there. I hope you can see it, guys. Maybe I can show you with this paper here. What we are saying, guys, is this, that if I come here and say differentiation of u all over, that is partial differentiation of u with respect to y, this one will give me y. I put it up here. I'll write x and then I put y there, negative 1. X is a constant. So I will now bring this negative 1 here, negative x, y, and then I say negative 2, like that. So that is my partial differentiation of this. This was supposed to be u, this one. So it comes to this. So in other words, guys, I have gone through a shortcut and come about with that, but this is how I have done it, guys. So it will be minus x all over y squared, like that. So then we can say we talk of v. Let me write v here. V now is going to be, the first one is u, we have v. The v is now going to be ln y, ln y. So that now partial differentiation of v with respect to y, this one now is going to give us 1 all over y, like that. So this is the product rule. So we come and now fix them here, guys. So now I will put u is x over y, like that. Then I will come and put now dv dx. Dv dx, of course, for this one is now y. This is y now for this. So I will put 1 over y here. That is 1 all over y. This will give us 1 over y now squared. I go now to plus, like that. For that, I will come and now say v. The v we have is ln y. So let me put ln y like that. And du, that is the partial differentiation of u with respect to y, is that. So this is negative x over y squared, negative over y squared. So guys, to write it better, I'll write it here. So our solution here now is this, that is partial differentiation of z with respect to y, now gives us x all over y squared minus x ln y all over y squared. So guys, that is on the right side. So let's find out what we get on the second, that is on the left side. On the right side, let's see what we shall get. So this one we call it equation 1. So we come now to the left side. Now we have x. There we have x. We can leave x first of all. Then we deal with this. But first, let me just write it, guys. X, like that. Partial differentiation, that is second derivative. Z with respect to y and with respect to x. So this one, guys, is similar to this x multiplied by partial derivative of, you write that first and then you write again partial derivative of z all over partial derivative of x, and then this is what you start off, guys. Maybe I can put it like that, and then you come and find the partial derivative of that with respect to y, like that, guys. So that's what I am going to do. So guys, I will start with this and see what I will get. So guys, we now come and do the next one. Remembering that our equation is like this. Z is equals to x all over y ln y. So now guys, we want to put this into practice and see what do we get. And so this is how we are going to do it, guys. We will come and say, I'll put this one this way. I'll put it as x, then ln y all over y, which is still the same as that. So the first thing I'll do is that I'll look for that. So in looking for that, guys, let me just write it here. I'll have that all over x, that is partial differentiation of z with respect to x. So all the other, apart from x, is a constant. So now we come and say, for this is like now we are given 2x, because this one we are considering y as a constant. So it's just like when you say differentiation of 2x, of which our answer then is 2. So our answer now is going to be ln y all over y. Ln y, that is ln y all over y. Now guys, we are over with that. We now come and do this. So now we are going now to come and do, now we put it like this. Like this, guys. Partial differentiation again of z with respect now to this one is here, x, like that. So this is what I have written here, that, and then now I have come and added that. So that this one now gives us is the same as, maybe I would have written like this, guys, to write it better. That z, and then partial differentiation of z with respect to x, z, and then I put partial differentiation with respect to that with respect to y's now. So this one is the same as this, and this one can also be given by, maybe I have written that a lot of times, squared z, that is second derivative, all over now both of that. So that's what we are now going to look for, guys. So already we have looked for the first one. This is the first one. Now we are looking for the one with respect to y. So this one will give us, we now come and use that. We shall have like something like this. Like that. So we come now to our equation here. This is now our equation, guys. We want to differentiate that with respect to y. So now we can see that we don't have a constant. So guys, what we can do, we can divide this equation into two. Like now we write 1 over y, then ln y. So guys, we can use now partial differentiation once again. So for this one, I believe, guys, we are going to be able, even without having to write the product rule. We use the product rule. Sorry guys, not partial differentiation, but product rule. So for the product rule, what we do, we first of all write this 1 over y. We don't differentiate that. And then now we come and differentiate that. If we differentiate that, you'll get 1 over y, which is now y becomes squared, plus, since we have differentiated this one, guys, now we have written this one first without differentiating. We have differentiated this one. So this is what now we are going to write first. Ln y, and then come and differentiate this. If we differentiate this, just as we found here earlier, guys, here we had 1 all over y somewhere. Let me see where we had 1 over y. This one was supposed to be 1 over y, because remember that x was a constant, so it's like we had a constant over y, and then we got negative 1 all over y squared. So that's what we are going to put here now. Negative, that now it's going to be negative 1 all over y squared, like that. So finally, guys, our equation then is going to be second derivative of z, that is partial, all over, or partial derivative, that is with respect to y, to x, and with respect to y. This now gives us now 1 all over y squared minus ln y all over 1. This is 1 over y squared. So what now, guys, we remain with is just to multiply by now the x. This is our x now, what we are going to multiply with now. So we multiply with the x, we will multiply this side with the x, then even this other side, we will still multiply by x. So finally our solution will be x all over y squared minus x ln y all over y squared, like that. And guys, this is now our equation 2. So guys, let's check and see whether our equation 2 is the same as equation 1. So this is our equation. Let's compare with our equation 1. Our equation 1, guys, is here. This. So if you compare that and what we have gotten here, guys, it now becomes the same. And so therefore, guys, we can actually now prove that, maybe I can now write down to show that we have been able to prove that this partial derivative of z with respect to y, therefore, is equals to x multiplied by partial derivative second of z with respect to x and with respect to y, like that. So guys, we have been able to prove, as you have seen. So guys, let me just leave you attempt now to do this other one. This one is easier, guys, so you don't have to worry. This is easier for you. Thank you, guys. Bye bye.